Hello children, hello everyone. In the last video, we understood some of the points or some of the problems in the circular motion. So today we're going to discuss more problems regarding the circular motion, that is uniform circular motion. Okay, let us see here. Given for fourth problem, up to third problem, I think in the last video we covered part 2 and part 1. Please watch the part 1 and part 2 so that you'll be clear with all the problems of circular motion. Here given two bodies of masses. Okay, two bodies are moving along a circular path with different speeds. This is V1 and this is a V2. The ratio of their angular speed is, you need to find the ratio of omega 1 by omega 2. Okay, children, this is what you need to find. Let us see. Write down V1, V2 given and omega 1 by omega 2 you need to find out. So we know that the formula V is equals to R omega, right children? V is equals to R omega. You need to calculate moving along a same circular path. Okay, because two are moving along a circular path means that what children, R1 is equals to R2. That is equals to just the same circle, both are moving with the different speeds, that's all. Okay, so that omega 1 by omega 2 is equals to, so if R is constant, omega is directly proportional to V, right children? Omega is directly proportional to V when R is equal. So that we can write here, in place of omega 1, omega 2, we can write V1 by V2. So here V1 given has in this problem it is 2 and V2 given has 4. So 2 V1 by V2 is 4. So 2 by 4 gives you 1 by 2. So this is what the ratio omega 1 is to omega 2 ratio of this is equals to 1 is to 2. So option 1 is to 2 is option B. Alright children, I hope this is clear. Let us hope the next problem, let us see. Here, see in this problem 5, what you need to keep in mind is that in uniform circular motion, radius decreases to its half of the initial value, then angular velocity is become. So one thing you need to understand here, in case of uniform circular motion, the formula, angular velocity formula is given by omega is equals to V by R. Since V is equals to R omega, right children, so that we can take omega is equals to V by R. And here they given radius is half of its initial value. So it is R prime is equals to R by 2. Okay, R prime is equals to R by 2. So let us write now omega change in angular velocity is given by V is constant and R changes to R prime. So in that condition, just V by R prime is nothing but R by 2. This 2 will come up, so it becomes 2V by R. So V by R, you know children, what is the formula of V by R? This is just omega. So V by R you replace with the omega. So it will come answer 2 omega. So that means change in angular velocity is 2 times the initial. So I can write it is option A. Okay, because omega prime is equals to 2 times of omega. Clear children? Next problem. See, in the problem given, the distance of the two particles or two planets from the sun are nearly. This is a R1 and R2. Okay, children, about the sun, this is sun is the center of the two planets. One planet is moving with this distance and another planet is moving with some increasing distance. 10 power of 12 and 10 power of 13 meters respectively. Then the ratio of their time period, you need to calculate time period if both are supposed to move with the same speed in a circular orbit. If the speed is given same, so V1 is equals to V2, R1, R2 are given. So you need to find the time period. Right, children? So you know linear velocity is given by what children? R into omega, where omega is given by 2 pi by 3. Okay, now you will get the relation between omega and V and T. R we can write this R and this R get cancels. Imagine, so omega is equals to 2 pi by T, right? So R we can write T1 by T2 is equals to R1 by R2. So this is the relation of T and R. So in place of R1, they given us 10 to the power of 12 and R2 given us 10 power of 13. So you will get cancel. So remaining is 1 by 10. So this is the answer, option D. Right, children? Let us see, children, the problem is given. See, the problem is like this. A stone is tied to the one end of the string of 1 meter long, is drilled in a horizontal circle with a constant speed. Okay, if the stone makes 22 revolutions in 44 seconds, then magnitude of the acceleration we need to find out. Clear, children? So here they given the 22 revolutions in 44 seconds. So angular velocity, how many revolutions, like 2 pi they given, theta given, and the time period they given. You need to find angular velocity, right, children? So, and the distance, radius of the circle is 1 meter they given. So this is the radius of the circle. This is the condition that the thread is there, a particle is there, it's going in a circular path like this. So in that condition, angular velocity omega is equals to theta by t, where theta is given as 22 revolutions, right, children? Given 22 revolutions by time period given as 44 into, see here, just to convert 22 revolutions, we can write it as a 2 pi radians, right, and 44 at the down. So cancel this term, children, you will get 22 and 22 2s are 44, again 2 get cancelled, so remaining here only pi radians per second. So pi radian per second is your answer, pi radian per second. So your answer is so this is angular velocity where they are asking angular acceleration. So angular acceleration, how are you going to calculate? Alpha is equals to or angular linear acceleration. So linear acceleration A is equals to v square by r. Okay, children, where v, what is the v value? Is the r omega. We can write it as also like a r omega square. So where r is a 1 meter, omega is a pi radian. So pi square, omega square is pi square. So totally what will get answer? Pi square radian per second square. Okay, so pi square radian per second square is answer. Not radian, sorry. It gives you the meters per second square, acceleration linear. So that the question 7 will get the answers as C. Okay, it's directed towards the center. Always the radial acceleration is directed towards the center. That is AN, that is given by the formula, that is V square by R. Understood, children? Next question, see. Here, the next question given like this: if a particle moves along a circle of radius is given as 2 meters, okay, radius is given as 2 meters, and acceleration is linear because meter per second square they given, that's a linear acceleration. Then its angular acceleration is, you need to find the angular acceleration. So let us see how to find this angular acceleration. You know the formula of angular acceleration, right, children? So angular acceleration is equals to r alpha, actually, alright, r alpha r. We can also write this as a by r is equals to, okay, a by r is equals to alpha. We can write r alpha is equals to a, acceleration given as 10 and the radius given as 2. So 10 by 2 gives you 5 radians per second. So this is answer B. Right, children, very simple. Just a conversion of this problem formula, A is equals to R alpha, so that you can be able to find the alpha, that is angular acceleration. Yes. So the next question, children, a body moves in a circle of radius 4 meters. Angular velocity changes from V and omega 1 to omega 2. Angular velocity changes from 20 to the 46 in the 4 seconds. So time is given in a 4 seconds. Angular acceleration of the body is, you need to find the angular acceleration. So the formula of angular acceleration, alpha is equals to, children, omega 2 minus omega 1 divided by time taken. So here given all the data, just substitute. It is 46 minus of 20 divided by time given as 4 seconds. So simplify this, you will get the answer. So 26 by 4 you will get 26 by 4, that gives you 6.5 radian per second square since acceleration. So here option C, option B is the correct. Next, a particle moves in a circle of radius of 0.5. Okay, radius is given as 0.5. Speed increases uniformly if the speed changes from 2 to 4. So V1 and V2, Speed is changing from this in a time of 4 seconds. Then angular acceleration. Here children, the data is given not angular terms, they are given in terms of linear. First you need to find linear acceleration, then you're going to convert that to angular terms. Right? So linear acceleration is nothing but final velocity v2 minus v1 or v minus u we can take by time taken. Either v2 is given as 4, v1 is 2 and time given as 4 seconds. So 4 minus 2 is 2 by 4 gives you 1 by 2 or 0.5 meter per second. So this is a linear acceleration, but they're asked you to find angular acceleration, so that angular acceleration alpha is equals to a by r, linear acceleration by radius of the circle. So angular acceleration, linear acceleration you got as 0.5, 0.5 by radius of the circle given as 0.5. Okay, 0.5 by 0.5 gives you 1. Right children, for this question answer is A, 1 radians per second square. Yeah, next question. Here a particle moves. A particle moves in a circle of radius 2 meters. Radius of the circle they given, and are moving with a speed 4 meters per second square. Angular velocity changes at the rate of 3 radian per second square. That means the given angular velocity rate of angular velocity is nothing but the acceleration. Okay, acceleration is given. So acceleration is 3 is given. So let us find the first question here, 11th one. Normal acceleration of a particle is given by children r omega square, right? So r we can write normal acceleration is equals to, we can also use this formula v square by r, where v is given as 4 into 4 divided by r, radius is given as 2. So simplify this, 2 ones are 2 2s are 4 and 4 2s are 8. You can write it as 8 meter per second square. Right children, this is a angular acceleration. So first question, it is answer B. Okay, 12th question, C. The tangential acceleration of a particle. The tangential acceleration is given by r alpha. Okay children, our radius is given how much? Radius is given as 2 meters into angular acceleration. Yeah. Here given angular acceleration is 3. Right children, alpha given as 3, so that you can multiply this, you'll get the tangential acceleration. Okay, 3 2s are 6, so this is your answer, meter per second. So this is the tangential acceleration. And next given total acceleration. Total acceleration is given by square root of radial acceleration and the tangential acceleration, where radial acceleration you got as 8 square plus tangential acceleration you got as 6 square. So 8 square is what children? 64, and 6 square is 36. So almost if you get root of 100, if you add this term, so root of 100 is, yeah, root of 100 is 10. Right children, this is the answer, 10 meter per second square. 10 meter per second square is answer. So option A is the correct thing. Understood children this question? Okay, this is regarding your circular motion problems. Let us see some more problems, little higher level of difficulty. Okay, here question number 4, given that is an object is moving in a circular path of radius is 1 meters if its linear speed becomes 3 times the initial speed. Its linear speed becomes 3 times the initial value. So v prime is equals to 3 times of the initial speed. Then angular speed, and what ratio the angular speed will going to increase, you're going to calculate children. So using this data, let us take this problem. Okay, children, this 14th problem is missing here. Okay, let us see. Given r is 1 and v is equals to 3v. So let us write omega 1 is equals to what children? Just it is omega only, and omega 2, that means change in angular velocity, we need to calculate. Right? So omega 1, your omega 2 is equals to, we can write v2 by r, where v2 is given. See in the problem, v2r, we can write v2 is equals to 3v and v is equals to, okay, v1 is equals to just a v. So V2 is equals 3V divided by R we got, where V by R, omega is nothing but what children? V1 by R only. So we get V1 by R is nothing but RV by R is omega. So we can replace this with omega. So if it is increased by angular velocity is increased by 3 times, then linear velocity is also increased by 3 times, or vice versa. If linear velocity increases by 3 times, means angular also increases by 3 times. So we can write here option A is the correct thing. Right, children? Yeah. Next question, 15th one. Given the time period of a particle moving in a circular path having a radius of 20 centimeter, a radius is given as 20 centimeter, is time period. Okay. Time period given as 3.14 seconds. The linear velocity of the particle. You need to calculate what? Linear velocity of a particle. So here linear velocity, you know that formula, children. R is equals to V equals to R omega, where omega is not given. So you need to find omega value. So radius is how much? It is a 20. Since centimeter is given, you can convert R because answer is there in meters per second. Centimeters also there. Let us try. 20 into, we can write 215 by 3.14. Okay, children. So gives you that 20 into 2, you will get almost. So 20 into 2, so how much, children? 40 centimeter per second, or it is 0.4 meter per second. Yeah, this is just a confusion solving problem. Just so omega value is children, it is actually 2 pi by t. Okay, where 2 pi it is not pi, 2 pi by t is there. So 2 into pi into t value is given, and you can write the pi value is also 3.148. So this 3.14, this will cancel. So only remaining is just 2 pi. Okay, children. So 2 into 3.14, right, divided by this t value is how much? It's also given 3.1. So this will cancel. Only remaining 2. Okay, children. This is what the 14th problem. Let us see 16th problem. I write here. 16th one, given angular velocity of a hour hand is 24. Okay, 24-hour clock. Hour hand, in the 24 hours clock you need to find out. So in the 24-hour clock, if you want to take, what will come? Omega is equals to 2 pi by t is a 24 hours. Okay. So just to convert this to radian per hour only they're asking. Okay. 2 by 24, what will be the answer, children? So we can cancel 2 and 12. So it will come pi by 12 will come. So pi by 12 is 3.14 by 12. So that gives you around, there is 0.26 radian per hour will get. Okay, children. So this is the correct answer. Option B. Okay, this problem answer B is the correct. Next one. A fan is making 600 revolutions per minute. If it makes 1000 revolutions per, then increase in its angular velocity is. Okay, you need to find here increase in the angular velocity you need to find out. So the 17th problem. See, children, this is not a given data. Given omega is equals to 600 revolutions per minute, means we can write 2 pi by 60, right? So cancel 0 0 and 6 ones are 6 tens are, so you will get 10 into 2, 20 pi. Understood, children? 20 pi radian per second we can write. So this is the answer. Okay, omega, this is the omega. They're asking increasing in velocity. No? So increase in angular velocity. Increasing in angular velocity is given by how much? 1200 minus 600 gives you what? 600 rotation per minute. So that will, what will happen, children? 600 revolution, that is nothing but again like this only. So what is the answer? 20. Okay, 20 pi radian per second. Okay, so this is the answer. 20 pi. Option D is the correct thing. Clear, children? Yes. Next one. 18th problem here. Okay. See 18th question. A car traveling in a circular path, okay, circular path with the radius of this. If the radius is given as 50 meters, if the speed is this and it is increases uniformly at this speed, then magnitude of the acceleration at that instant you are going to find out. Children. So that acceleration, magnitude of acceleration is given by square root of radial square plus the tangential acceleration square. So that is given by radial acceleration. So how to calculate radial acceleration and tangential acceleration? You know the formula actually. An is equals to what and At is equals to what. So you just calculate using that formulas. Simple, try it children. So you'll get that answer. It comes around 5.12 whole square plus of 8 square. 80 will come 8 square. So if you simplify this, you will get around 9.5 meter per second square. So 9.5 meter per second square, you get the answer. Let's try it. Find An and At using the given data. An formula and At formula substitute. And then solve. You know, children, I hope you can know An is going to be V square by R and At is nothing but tangential is R alpha. So use this formula and try to solve this. Next. A wheel is at rest. Okay, a wheel is at rest means initial velocity of this is 0. Its angular velocity increases uniformly, becomes 80 radians after 5 seconds. Okay, it is omega 2, omega 1 and omega 2 under time given. Then the total angular displacement you need to calculate. Yes, angular displacement in that condition S is equals to ut plus half at square. You know this formula actually. Ut plus half at square. Yes. In case of linear form, we're going to write this equation S is equals to ut plus half at square. In case of angle, in case of theta, yes, we can write theta. And here initial velocity, however, 0, only final will come. So we can write half in case of alpha, it is at square. Okay, theta is equals to half at square. This is the displacement of the particle. We're going to find using this. So that is given by angular displacement is given by half into. In case of alpha, change in velocity we can write is 80 minus of 0, initial it is 0 divided by time. Time given as 5 seconds. So this is the equation we got. So now you simplify this children. So 80, up it is 80 and down it is 2 5s are 10 is there. So simplify this. So what you will get? Okay, one more thing is t square, right? Half into alpha into t square. T square is 5 square is there. So 5 square get you 25. Alright children, so simplify this. 2 5s are 10, so 2, okay, 2 5s are 5 2s are 10 and 5 5s are 25. So 80, you can get this one, you cancel with the 40. So you'll get 40 into 5 is there. So 40 into 5, what is the answer children? 200 radian per second. This is your correct answer. I hope option C is the correct, right? Yes. 20th question. Say, given a particle moving along a circle of radius. So radius is given with a constant tangential acceleration. Given At is equals to constant. And if velocity of the particle is velocity of the particle given linear velocity at the end of the second revolution after the motion has begun. Okay, then tangential acceleration is after 2 revolution, end of the second revolution, this is the tangential acceleration is constant. But when it is began, what is the tangential acceleration they're asking, right children? So after second revolution, At is equals to what we need to find out. So after second revolution, imagine if the particle is going in one revolution, it is 2 pi. If the same particle, one more revolution, it will cover angle of 360 plus 360, so 2 pi plus 2 pi. So that is the total displacement of the particle. Total is 2 plus 2. 4 pi is the total displacement of the particle. Right, children? Understood? In covering one circle, 2 pi. In a one more circle, one more time, it is 2 pi. So the displacement of the distance, total distance covered by the particle is 4 pi. This is the distance covered by the particle. So using this, you know, omega is equals to children, it is V by R. Right, omega is equals to V by R, where V is given as linear speed, it is 80. Okay, 80 is pi divided by 2 pi. In the sense, it is 8 pi because pi means 4 is given. So divided by r, radius is given as 20. So cancel the terms, what you will get? 4 pi is the angular velocity. So you need to find change in velocity. So alpha is equals to what, children? Change in velocity by time, right? So like this, we're going to find the change in velocity. That is 4 pi square, right, children? 4 pi square minus of 0, because angular initial it is 0, is equals to 2 alpha into 4 pi. So can you guess what is the formula I wrote? This is the formula. Omega 2 square v square minus u square, right, children? V square minus u square is equals to 2as. In the place here, 2 alpha into theta. This is the formula I used. Okay, from this formula I wrote this equation. So now again I simplify. 0 square is 0, 4 pi square you can write it as 16 pi square, and left hand side it is 2 4s 8 pi alpha. Okay, so cancel the terms of both the sides. So you will get the alpha is equals to, okay, right, children? So both the terms 5 pi get cancelled, 8 1s are 8 2s are cancelled. So 2 is left and pi is left, right, children? This side 2 pi is left, that's all. So alpha is equals to 2 pi is there. Okay, children. So 2 into pi value is there. This is the alpha. But what you need to find? You need to find a linear acceleration, right? Linear acceleration or tangential acceleration is equals to, children, r into omega, right? Tangential acceleration is r omega, where r is given as how much, children? It is 20 by pi radians. So this is your r is given. Yeah, r is given as 20 by pi r omega r alpha. Alpha is 2 pi. That's right. So pi get cancels. 2 into 20 into 2 gives you 40 meter per second square. Right, children? So this is the answer. C is the correct thing. Okay. I hope this is clear, children. Last problem. If a particle moving along a circular path of radius of 5 meters with a uniform speed of 5 meters per second, then average acceleration when the particle came to half of this revolution. Average acceleration and the half of the revolution. That means a particle going like this in the half of its revolution, but here to here, when it is covered, what is the angular acceleration interval? When it is cover here, total angle from here to here particle is moving. Imagine how much angle it will traces by 180 degree going to trace. R is given. Okay, V is given, acceleration into point in half of the revolution. In half of the revolution, what is the V, children? V is equals to, we can write S by T, R. T is equals to, children, V, what will get? V is equals to theta by T, we are going to write. Okay. Okay, children, the last problems I'll explain in the next video. Thanks for watching, children. Have a nice day. Bye.